Welcome to this video. So this is our third video for the assessment purpose of an assignment by the Skyfi Labs. In the previous videos, we have seen the modeling and analysis of a 23-story building using ETABS. We have also seen the applications of dead, wind, live, and seismic loads on the same building. Now, we will be designing a mat footing for the same building using SAFE 2016. The links for the previous videos are provided in the description. So now we'll look for the problem statement. It shows us there are a total number of 16 columns in this building plan, which are 6 meters apart from each other in both x and y directions. We have to assume a safe bearing capacity of 300 kN per meter square with an allowable settlement of 1 centimeter. We have to provide a bar size of 22 mm with the rebar material as H5SD 500 and a concrete grade of M40. These are the dead loads and the live loads values which we have acquired from the analysis results from the ETABS. We have to keep a note of these 4 columns as they differ in dimensions than the other columns. So for the subgrade modulus, when we divide SBC by the allowable settlement, it gives us 3 into 10 raised to 4 kilonewton per meter cube. For the column strip width, both our L1 and L2 is 18. That is 6 times 3, it gives us 18. So our strip width comes to 4.5. But for this model, we'll consider the strip width of 4 meter. So the interior part is the actual plan of the building, and the mat footing will be underneath this, will be extended on all the sides to cover the corner columns. So we'll design a footing which is extended 2 meters from all the sides, which means that the actual length and breadth of the footing becomes 22 meters by 22 meters. So we'll start the modeling. Open the SAFE 2016. Now we'll do the initial settings. Click on File and select the new model. Here we have to change the design code to IS 456-2000. Make sure the units selected are currently metric. We'll change the design preferences. So we'll click on Modify Show option and go to minimum cover slabs. We'll change the clear cover for top and the bottom to 50, and as given in the problem statement, we'll change the bar size to 22 and then click on OK. Now we'll select the grid only option. The number of grid lines option will provide a grid lines of 19 in x direction and 19 in y direction, and a grid spacing of 1 meter between each of them, and then click on OK. As you can see, our grids are generated. Now initially we'll define the material properties, that is the concrete grade M40 and the rebar of H5SD 500. So now we'll go to define, select materials, click on add new materials and change the material name to M40. Change the material type to concrete and add the standard values for the material weight that is 25, and the standard values for other options too. After adding the standard values, we'll click on OK. Similarly, we'll have to add a new material for the HMISD 500 bars. Change the material type to rebar and again add the standard values and then click on OK. You can see we have generated the material properties. Click on OK to exit. So now we have to define the column properties. So we'll go to define and click on column properties. We have to add two column dimensions as discussed earlier, that is the 600 by 600 mm and 500 by 500 mm. So we'll click on add new property, change the column name to all 500 by 500, change the material type to M40 and change the dimensions and just click on OK. Similarly, we'll add a new property for the other column of dimension 600 by 600, change the material type to M40 and the dimensions to 600 and then click on OK. Click on OK to exit. Now we have to define the slab property. So we'll again go to define and click on slab properties. Click on add new property option. Change the property name to mat footing. Change slab material to 140 and change the thickness to say 500 mm. Change the slab type to mat and click on OK. Again, we'll click on OK to exit. Now we have to draw a slab of 18 meter by 18 meter initially. So we'll go to draw and click on draw slab slash areas. Make sure the property selected is mat footing and then using the help of grid lines we'll draw the slab. We have to return the first point, draw the slab. So as we can see, we have drawn the slab. Click on escape. Now as discussed, extend the slab by 2 meters in both the direction. We'll click once on the slab, make sure our selection, then click on edit and click on edit areas and select expand or shrink areas. So we'll give an offset value of 2 meter, that is 2000 mm, and click on OK. So as we can see, our mat footing slab is generated and extended for 2 meters from all the sides. Now we'll draw columns on this slab. We'll go to draw and click on draw columns option. So we'll first draw the column with dimensions 500 by 500. Change the property below to null and change the property above to column 500 by 500. Change the height below to 0 and change the height above to 2. And with the help of the grid lines, we'll place the columns 6 meters apart from each other carefully. As we have seen, there are 4 columns which differ in dimensions. So we have drawn the column of 500 by 500 mm. Now we'll go for the column of 600 by 600 mm. So select the property above to column 600 by 600, and then with the help of the grid lines, place those columns carefully. So as we can see, we have drawn all the columns. Click on escape button. Now we have to draw the design strips. So again we'll go to draw and click on draw design strips option. First we'll draw the strips A directions, that is in X direction. We'll change the strip width to 4 as discussed earlier. The answer came to 4.5, but we'll be considering 4-meter strip starting from the end of the footing from right. We'll draw the column strip very carefully, passing through the midpoint of the columns and click outside the footing to exit the drawing mode. Similarly, we have to draw more 3 strips. So we have drawn the strips in X direction. Now we'll draw the strips in Y direction. We'll change the strip layer to B. We have to draw the column strips very carefully. See, it should pass from the center of the columns. Similarly, we have to draw strips for the other columns also. We have drawn all the column strips. Click on escape. In order to see these column strips, we have to click on the set display option. Select the design strip objects. Check all the 3 boxes and click on OK. As we can see, the column strips. Again, we'll go to set display options, deselect all the 3 options and click on OK. So we have forgot to define a very important property, that is the soil subgrade property. We'll define it now. We'll go to define, click on soil subgrade properties and click on modify show property. We'll change the subgrade modulus which we have calculated 3 into 10 raised to 4, that is 3e plus 04, and click on OK. Click on OK to exit. Now we have to check the load patterns and load cases, also the load combinations. We'll go to define load patterns. Dead and live loads are already present. Click on OK. Again define load cases. Both dead and live linear static load cases are present. OK. We'll again go to define and load combinations, where you have to add two combos. Click on add new load combo. We'll keep the load combination name as comb1. Change the scale factor to 1.5. We'll add the combo for live load. Change the scale factor to 1.5, and from the design selection we'll select the strength and click on OK. Again we have to add a new combo. We'll keep the load combination name as combo2. From the load name option we'll select dead and add a scale factor of 1, and again we'll select live and add a scale factor of 1 again, and select the other three options from the design selection and click on OK. Again click on OK to exit. Now we'll assign the defined properties to the elements. Click once inside the flap, the area of footing. Make sure your selection. Go to assign, support data, soil properties. Click on OK. Again we'll go to assign. We will select the area of footing. Click on escape. Select the area of footing. Make sure the selection. Go to design, slab data. So select matte footing and click on OK. As you can see, matte footing is appeared. Now we'll assign the rebar material. Right click on the slab area, go to design and change the rebar material to H5SD 500 and click on OK. Again click on OK to exit. Now we have to change the rebar material for the design strips, so we'll click on the design strips and change the rebar material to H5SD 500 and click on OK to exit. Similarly, for all the design strips, we'll change the rebar materials. Change the rebar material for all the column strips. Now we'll be assigning the loads for the columns. For this, we'll start with the first column. As earlier, we'll go in the proper direction, that is, we'll start with C1. We have to make sure that the four columns, that is the C6, C7, C10 and C11, have different dimensions. So we'll first add the nodes for the similar column dimensions, that is 500 by 500. So click on the grid point, make sure your selections that one point is selected. We'll go to assign, load data and point loads. Make sure the load pattern selected is dead, and as per the given table, we'll add the loads. Change the side of the load for punching shear to 500 in X dimension and 500 in Y dimension, and click on OK. Similarly, we'll again select the point, go to assign, load data, point loads, change the load pattern name to live, and add the live load as per the table. We'll keep the size of the load punching shear dimensions similar to the early. Click on OK. So as we hover over the cursor, we can see it shows in the left corner that Fz equal to 797.6 kilonewton in bracket live. Similarly, we have to work for the other columns. Make sure your selection that you don't select the column strip. We just have to select the grid point, go to assign, go to load data, select point loads, change the load pattern name to dead, change the dead load to 3013.3 as per the table. Click on OK. Again, on the point, go to assign, load data, point loads, change the load pattern name to live from the table 1437. Click on OK. As these columns are of similar dimensions, we don't have to change the size of load of our punching shear. We just have to change the dead loads and the live loads. So as we complete the assigning of dead loads for the column dimensions of 500 by 500, we'll go for the other column dimension, that is for column say 6. Select the point, go to assign, click on load data and select the point loads option. Change the load pattern name to dead. From the table, we'll add a load of 5414.9. Now we have to change the size of load for punching shear for 600 in both X and Y dimensions and click on OK. Similarly, select the point again, go to assign, load data, point loads, change the load pattern name to live, and from the table we'll change the load to 797.8. Click on OK. Similarly, we have to work out for the other three columns, that is C7, C10 and C11. So we have added all the dead loads and live loads to the columns. As we hover over these columns in the downward left window, you can see it shows us the live loads. Now for the 3D view, we'll select the set display option. From the options, we'll select the extrude view option and click on OK, and then click on 3D. So we can see in the 3D view a footing is generated. Now we'll go to X5 plan view. Again, go to set display options and deselect the extrude view and click on OK. Now we have to run analysis on the footing. So we'll go to run and click on run analysis. Ask us to save the file. Give us a table name and then click on OK. Now we will run analysis on the footing. So we'll go to run and click on run analysis. So it will show us the deformed shape in the displacement diagrams. Now again we'll go to run and click on run analysis and design. As we'll go to display and now click on show punching shear design. As you can see, the punching shear values are more than 1. We require the punching shear values less than 1. So now in this case we have to redesign the footing. So we'll now unlock the model, click on OK, go to define slab properties, click on modify shear property, and we'll change the thickness of the slab to 900 mm and click on OK. Again click on OK. Again we have to run analysis, then we'll go for the analysis and design, and again we'll go to display and click on show punching shear design. Yet some of the columns values are more than 1. So again we have to redesign and unlock the model again. Go to define slab properties, click on modify show property and change the thickness to say 1400 mm and click on OK. Again click on OK. Again we'll click on run analysis, run analysis and design, and then on display and on show punching shear design. Now as we can see, all the members, all the columns values, that is the punching shear values, are less than 1. Now we'll go for the detailing. We'll go to run and click on run detailing option. Make sure you selected the 3 checkbox and click on OK. Now we can see the detailing diagram. Now we will interpret the results. We'll go to drawing sheet components and slab views, rebar schedule. So as we can see, it shows us the rebar schedule. We click on bill of quantities. So it shows us the bar size, the length, and the weight of the bar. So it shows us different bar sizes with the length and weight. This completes our project on matte foundation. Thank you.